Today we want to learn how we can balance redox reactions in acidic medium. We want to learn how we can what? Balance redox reactions in acidic medium. We know that redox reactions are reactions involving both oxidation and reduction. Reactions involving both oxidation and reduction. And we know that there are a number of definitions for oxidation and reduction. For example, we could say that oxidation is the addition of oxygen, while reduction is the removal of oxygen. We can say that oxidation is the removal of hydrogen, reduction is the addition of hydrogen. Oxidation is the increase in oxidation number or loss of electron. We could say that reduction is what? Decrease in oxidation number or gain of electrons. Oxidation is what? The addition of electronegative elements. Reduction is what? The removal of the addition of electropositive elements or removal of electronegative elements. These are the definitions for oxidation and reduction. We will actually be applying one or two in this from the definitions. But I believe that before we can do this, we should have a good knowledge of what oxidation and reduction reactions. So actually, a redox reaction is a reaction that involves both oxidation and reduction. So when we have a question like this, how can we balance this redox reaction in acidic and basic medium? There are actually a number of steps that we need to use before we can balance this equation, okay? One is that we are going to identify the oxidation half equation and the reduction half equation, because we have said that this reaction involves oxidation and reduction. So definitely we should be able to identify which of the atom or species has been what? Oxidized or reduced. And we should be able to identify the oxidant, that is the oxidizing agent. And at the same time, we should be able to identify the reductant, that is the reducing agent. We should know that an oxidizing agent is that substance that is what? Reduced in a chemical reaction, thereby what? Oxidizing another substance. A reducing agent in its own case is always what? Oxidized. So how do we identify all of this? So let's start. The steps are 6. We are to identify the oxidation half equation and the reduction half equation. That's the first thing. The second thing is that we are going to balance the atoms. That is, we are going to balance the reactions, okay? We are going to balance the atom except those of hydrogen and oxygen. The third one is that we are going to introduce water molecule so as to what? Balance oxygen. Then the fourth one is that as a result of our addition of water molecule, we will need to balance the other side with hydrogen ion. Then the next thing we are going to do is we balance the charges. After balancing the charges, we sum up the reactions. All these things that I have said may appear cumbersome, but it's very simple. The application of what I have said is going to be done now. So let's follow me. Now, looking at this reaction, like as I said, it's a redox reaction, meaning that there is oxidation and there is reduction. So now, why balancing of redox reaction is a bit more tasking? Because you are not only balancing the individual atoms, no, you will also balance the charges. We are balancing the atoms and what? The charges. If we look at a chemical reaction, normally, let's say for example, the Haber process for the production of what? Industrial production of ammonia. Let's say we have nitrogen gas and hydrogen gas producing ammonia gas. For me to balance this reaction, I have got no charges, so I'm not dealing with charges. I want to balance only the atoms. All I have to do is I have 2 atoms of nitrogen here, I have 1. I can write out the atoms like this. This is for nitrogen, this is for hydrogen. On this side I have nitrogen, I also have hydrogen. I have 2 atoms of nitrogen here, I have 2 atoms of hydrogen here. However, on this other side, that's for the product, I have 1 atom of nitrogen and I have 3 atoms of oxygen. So if I look at the reactants, I have 2 atoms of nitrogen, but I have 1 atom of nitrogen. So to make this balanced, I can easily add 2 here, so that my nitrogen will become 2 now, isn't it? But as a result of the addition of these 2, the number of atoms of hydrogen has been changed. 2 times 3 is going to give me 6, so I have hydrogen to be 6. So if I look at this, my nitrogen is balanced, 2, 2. But then hydrogen is 2 here, it is 6 here. So in order to make that up, it is very simple. By the time I put 3 here, I'm going to have 2 times 3, so that is what? 6. So balancing a regular chemical equation like this is very simple because you balance only the atoms. Now let's come back to redox reaction that has to do with balancing of the atoms and the charges. So as I said, there are a number of steps. Step 1 is what? We want to identify and write out the oxidation half equation and reduction half equation. Before we can half, that is half of this equation will be written out. That's the meaning of the half equation. We are going to see it now. So we need to identify oxidation and reduction in this reaction before we can move on. So let's see how we can identify that. Now, I need to know the oxidation number of each of the atoms here for me to know which one is oxidized, which one is reduced. Okay? To get the oxidation number of manganese in this compound, what I have to do is write out, let's say I'm representing my manganese with X, and then I'll add it to, I have 4 atoms of oxygen, that will be 4 into, the oxidation number of oxygen is always -2, except in peroxides, okay? So, and this is not a peroxide, so we have -2, which is equal to, now, the net charge here is what I'm going to get as my result on the right hand side, which is -1. That is simply -1. So if I open the bracket, I'm going to have x plus times minus is minus. 2 times 4 is what? 8, which is equal to -1. So my x is going to be -1 plus 8. That implies that, so -1 plus 8 is what? 7. That means this manganese has a net charge, has a charge of +7. And as I said earlier, my oxygen is always what? -2. Now, what's the oxidation number of this tin? This is tin 2 ion. The oxidation number is simply what we have at the top, which is what? +2. Manganese, oxidation number is +2. Then for tin here, we have oxidation number of what? +4. And one of the definitions of oxidation that I gave earlier, you can go back to the video to check. I said that oxidation can be defined as what? Increase in oxidation number. While reduction is what? Decrease in oxidation number. So we are going to apply that definition now. Now, if we look at this, manganese was +7 here, but here it is now, it is +7 here, but now it is what? +2. So that implies that there is a decrease in the oxidation number of manganese from the left hand side to the right hand side. So that decrease in oxidation number is called what? Reduction. So that means reduction has happened here. The oxidation number of tin here is +2 and it has increased to +4. So increase in oxidation number is simply what? Oxidation. So it is easy for me now to write out my oxidation half equation. This is oxidation, so I'm going to have tin 2 ion going to tin 4 ion. So this is my oxidation half equation, while this MnO4 minus going to Mn2 plus is going to be my what? Reduction half equation. It's as simple as that. So I'm done with step 1. Now what's my step 2? Step 2. For step 2, actually, I will balance the atoms except those of hydrogen and oxygen. That is, balance the atoms except those of hydrogen and oxygen. Now, if I look at this, I have SN2 plus going to SN4 plus. I want to balance the number of atoms. I have one atom of tin here, one atom of tin. Forget about the charges. I am not dealing with the charges, I'm dealing with the number of atoms. So I have one atom of tin here. I also have one atom of tin here. That makes it balanced on both sides, isn't it? Now, the next thing I would have to do now is to look at the equation again. Let me go to the next one for reduction half. So I am not balancing hydrogen and oxygen because I do not have hydrogen and oxygen. So that means I'm done with this step. So let me now look at the next equation. We have MnO4 minus going to what? Mn2 plus. So if I look at these two, I want to balance this equation. This is one atom of manganese, one atom of manganese. but the instruction is that I should not do anything to those of hydrogen and oxygen. So I will not work with anything here. So that implies that automatically we are done with step 2. Now, step 3. Let's move on to our step 3. So, for step 3. Now, what I want to do in step 3 is that for the side that is deficient of oxygen, I will introduce water molecule. Looking at these two equations, this has got nothing to do with oxygen, so I will move on to this. So this side has this, on the right hand side, I do not have oxygen. So as to have oxygen on this side, okay, I will bring in water molecule. So let's see what we are going to have. Let's say to the side deficient, to the side deficient of oxygen, to the side deficient of oxygen, add appropriate number of water molecules, okay. Now, since I'm dealing with only this equation, let me write it out. I have MnO4 minus going to Mn2 plus. So this side is deficient of oxygen, so I need to add water molecule. So I will add water molecule. But appropriate number of water molecule, this is what will make me know it. Of oxygen actually. I have 4 atoms of oxygen, so I have to write 4 here. So that at the end of the day, I will have 1 atom of manganese, 1 atom of manganese. 4 atoms of oxygen, 4 atoms of oxygen. So I'm done with step 3. I wouldn't apply that to this because I do not have oxygen in any of the sides, whether the left hand side or the right hand side. Okay? So I'll move on to step 4. Now, for step 4, all I have to do is, if you look at step 3, something has happened. On this side I have manganese and oxygen, while on this side I have manganese, hydrogen and oxygen. So because of the addition of a water molecule, hydrogen has been added here. So I'm going to balance the equation with hydrogen ion, which is proton. Is that okay? So I'll bring in hydrogen ion to this side so that I'll be able to balance with hydrogen. So I have MnO4 minus plus hydrogen ion going to Mn2 plus 4H2O. So now, this is manganese, this is manganese, this is hydrogen, oxygen, oxygen. I do not have any issue with the equation again. Only that I have to balance. Now, I have an atom of manganese, 4 atoms of oxygen, 4 atoms of oxygen. But here I have 2 atoms of what? 8 atoms of hydrogen, because 2 times 4 is going to give me 8. But I do not have 8 here, so I'm going to put 8. So that makes this equation to be what? Balanced in terms of what? The number of atoms. So the next thing I will do is to move on to step 5. So what I want to do in my step 5 is simple. All I have to do is balance the equation with electrons. I will balance the equation with what? Electrons. Now let's look at this. I have left this equation from step 2 because it is not going in line with the instruction, okay? So that means the only one I have to balance for now is what? This. But by the time I balance this, if I take this equation to step 3, I will not be able to apply anything. If I bring it down to step 4, I will not be able to apply anything. So I don't need to bring the water molecule or hydrogen since it has got no oxygen here. But I will have to balance the charges too with electron, isn't it? So let me first work with this. Let me bring out this equation. I have MnO4 minus plus 8H plus going to Mn2 plus 4H2O. By visual inspection, the net charge here, the original number of this place, the net charge here is -1. The net charge is -1. Now, plus, what's the net charge here? The net charge here actually is going to be +8. Why? Because this 8 implies that there are 8 atoms of H plus. H plus, H plus, H plus. 1, 2, 3, 4, 5, 6, 7, 8. So instead of writing it one by one like this, that's why we have 8 H plus. That implies that I have 8 charges here. So I have a charge of what? Plus 8. Now, minus 1 plus 7 here is going to give me 7. That implies that the net charge on the left-hand side of this equation is what? Plus 7. Now, let me move on to the right-hand side. For the right-hand side, I have a charge of what? Plus 2. And don't forget that when you have a molecule or you have a compound like this without no net charge, the oxidation number of the molecule is actually what? 0. So that's plus 0. Plus 2 plus 0 is going to give me plus 2. So that implies that the net charge here is plus 7, the net charge here is plus 2. Good. I want to balance with electron. This is how to indicate an electron. Electron comes with a negative charge. So if I have a charge of plus 7 here and I have a charge of plus 2 here, if I bring in electron to this side, it's going to be favorable because it's going to deduct it. So I need to bring in, how many number of electrons do I need to bring in? To reduce this to 2, I need 5. Because an electron carries a net charge of minus 1. Do you understand? Carries a charge of minus 1. So what I'm going to do now is bring in 5 electrons here. So I will have MnO4 minus plus 8H plus plus 5 electrons going to Mn2 plus plus 4H2. So with this, I've been able to balance the charges. Minus 1 plus 8 is plus 7. Plus 7 minus 5 is 2. And on this side I have 2. That implies that the number of atoms are balanced, the charges are also balanced. Now let me come back to this equation. I have Sn2 plus going to Sn4 plus. So I have a charge of plus 2 here, a charge of plus 4 here. And I say I want to balance with what? Electrons. My electron carries a charge of minus 1. So I need 2 electrons actually to reduce this plus 4 to what? Plus 2. So I'm going to have Sn2 plus going to Sn4 plus plus 2e minus. So that at the end of the day, plus 4 minus 2 is going to give me plus 2. Then I have plus 2 here. So the charges are balanced. Then at the same time, the number of atoms are balanced. Okay? That is step 5. Now, before I can proceed, I want the number of electrons. Let's say this is my equation 1, and let's say this is my equation 2. I want the number of electrons on these two equations to be equal. So if we go back to our basic maths, we should know that if I want to equate these two together so as to get the same number of electrons here, all I have to do is multiply this equation by 2. Then multiply this equation by what? By 5. So that 2 times 5 is going to give me 10, 5 times 2 is going to give me 10. So now, we are going to have the result of this. 2 by this is going to give me 2 MnO4 minus plus 2 times 8 is what? 16H plus 10E minus, then 2 Mn2 plus 2 times 4 is what? 8H2O. Then if I come here, I have 5 Sn2 plus, okay, going to 5 Sn4 plus 10E minus. Wow, I have it. 10E minus, 10E minus. So I'm going to go to my final step, which is step 6. So I'm going to step 6. Step 6. So for my step 6. So my step 6 is simply that I will sum up the equation, okay? What I have on the left hand side and the left hand side of these two equations will be on the left hand side. So then this and this, I'll put it together on the right hand side. Now let's look at it together. I have 2 MnO4 minus plus 16H plus 10E minus. Then on this side I have plus 5 Sn2 plus. these are the things I have on the left hand side, isn't it? Now, going to, sorry, I will have to drop this off. Okay, now we have 2Mn2 plus 2Mn2 plus 8H2O plus, no, this side, 5SN4 plus, then plus 10 minus. Now, by visual inspection, I see that this is equal to this, so they can cancel out. This will cancel out. So my final equation is now going to be 2MnO4 minus plus 5SN2 plus. Just a bit of rearrangement. Then I'll bring my plus 6H plus. Look at 2MnO4, this is it. 5SN2 plus, this is it. 16H plus, this is it. And this has been used to cancel that out. Okay? And I have my 2Mn2 plus 5SN4 plus, then plus 8H2O. So this is the balanced equation. So I've been able to balance this in what? Acidic medium. Just 6 steps, and this is as simple as that. Now, I need to check if this is balanced actually, truly, so that I wouldn't be having any problem. Okay? So now let's check. Let's check. So I'm going to check the number of atoms if they are balanced on both sides. I have manganese, I have oxygen, I have tin, and I have hydrogen. The same thing applies here. I will have manganese, oxygen, tin, and hydrogen. What's the atoms of manganese here? We have 2. For oxygen, I have 2 times 4, which is what? 8. For tin, I have so if you look at this, I have 5 atoms of Sn. So that's just simply what? 5. Then for H, I have only 16. I'm dealing with the atoms, not charges. Atoms, forget about the charges, okay? Then here, I have manganese to be 2. I have oxygen to be 8. I have tin to be 5. And I have hydrogen to be 16. 2 times 8. So, for the number of atoms, manganese is balanced, oxygen is balanced, tin is balanced, hydrogen is balanced. Now, let me check the charges. Let me check the what? The charges. So, let us check the charges. Now, I have a net charge of -2, because this implies that there are 2 of these. What I have is MnO4 minus and another MnO4 minus, isn't it? 2 atoms of MnO4 minus. So that implies that the 2 will have a net charge of what? -2. Then here, plus, I have 5 atoms of Sn2 plus, meaning I have Sn2 plus, Sn2 plus, Sn2 plus, Sn2 plus, and Sn2 plus in 5 places. So what am I going to have for the charges? For the number of atoms, it's simply 1, 2, 3, 4, 5. But for the charges, 2, 4, 6, 8, 10. So plus 10, plus, the same thing applies to this. I have 16 of each plus, so I'll be having 16. -2 plus 10 is what? 8. 8 plus 16 is 24. Now on this side, I have a net charge of +4 because I have 2 of this. So that's +4 plus 5 of this is going to give me what? 20. Then plus, don't forget that for this molecule of water, without a net charge, it is what? Automatically 0. So +4 plus 20 is going to be what? 24. That means that the charges are balanced, the number of atoms is balanced. So that implies that this is correct. So, for you to be able to try out questions on your own, let me give you an assignment. So you can try this. You can try this on your own. Try this on your own. balance this redox reaction in acidic medium, following the steps I've given you earlier. So you can check the next video for the correction on this. Thank you for watching.